So 8.5, so we're going to do binomial theorem. Binomial theorem is not that difficult, but it looks a little bit crazy. But really, it's just a formula. So it's not that big of a deal. So let's talk about what we would need the binomial theorem for. So whenever we have stuff like expanding a plus b squared, and I know you guys know, oh, well, since there's a plus sign, then we need to write this out twice and FOIL. And you end up with a squared plus 2ab plus b squared. And that doesn't take too long, right? That's okay. But what about whenever it gets a little bit more, when we get a higher power and a higher power and a higher power? That's whenever it starts to take a lot of time. It can start to get a little bit confusing. So for this a plus b cubed, we would take a plus b and multiply times, we already did the a plus b squared up here. So a squared plus 2ab plus b squared. And then the way to work that out is we're going to distribute this a to everything. So when we distribute that a, the a times a squared gives us a cubed. A times 2ab is going to give us plus 2a squared b. And then a times b squared is going to be plus ab squared. And now we need to multiply this b times everything. So b times a squared is going to be plus a squared b. B times 2ab is going to be plus 2ab squared. And then the b times b squared is going to be plus b cubed. And there we go and combine like terms. We're going to have the a cubed. We have a 2a squared b and an a squared b. So we can add these because the a squared b's match. Those are like terms. So we're going to have plus 3 a squared b. And then we're going to look at the ab squareds. So we have an ab squared and 2ab squared. Again, they're like terms because we have the ab squared matching in both. So plus 3ab squared. And then we just have this plus b cubed left. So we can do this, but it just takes a little bit of time. And we could technically go through and work to the 4th, to the 5th out, but it's going to take more and more time. And if we have to like to the 32nd, there's no way we really want to do that by hand. So this is why we have the binomial theorem. So it's going to give us the formula or show us the pattern for whenever we're doing these binomials, so the a plus b, whenever we're doing those to different powers. So, and same idea here. It's not always going to be just a and b. We could have 3x and then negative 5 for b. We could have even things more complicated than that. So instead of a, maybe we have 3xy. And instead of b, maybe we have a negative 6z cubed or something like that, to where it can start to become a little bit more complicated. So for us to go through and expand these things, again, we can walk through and go through and cube everything, or we just worked out up here a plus b cubed. So since I already worked out a plus b cubed up here, if I substitute 3x in for a and substitute negative 5 in for b, I can actually just replace all these a's and b's with 3x and negative 5 and get what I would have gotten if I had gone through and worked this out. So instead of the a's, I'm going to put in 3x, because I'm just going off of this one where I've gone ahead and simplified it. So again, we're plugging in the 3x for a, so we've got 3x cubed plus 3 times 3x squared, and then we're going to plug something in for b, and then plus 3, and instead of the a, we're going to have 3x, and then I'll plug something in for b, and then plus, and again, we'll plug something in for b. And for the b, we're going to plug in negative 5. So 3x cubed plus 3 times 3x squared, and then the b is going to be a negative 5. And then plus 3 times the a, which was 3x, and then times the b squared. So that's a negative 5 squared. And then plus b cubed, or a negative 5 cubed. Let me make that a little bit smaller. There we go. And we do this, so 3x cubed, so 3x times 3x times 3x is going to give us 27x cubed. And this is going to take a little bit of thinking. So we've got the 3x squared. Well, the 3x squared is 9x squared. 9x times 3 is going to give us 27x squared. And then times this negative 5 is going to give us a negative 135. So we have a negative 135 x squared. And then we need to work this one out. So I'm going to start again the one that has the exponent. So the negative 5 squared, because the negative 5 is the negative 5 being squared. So negative 5 times negative 5 is going to give us a positive 25. So 25 here. And then times 3x is going to give us 75x. And then times 3 is going to give us 225. Is that right? Thank you. So plus 225x. And then here plus a negative 5 cubed. Negative 5 times negative 5 times negative 5. 3 negatives is going to end up with a negative. We're going to end up with a negative 125. Is that okay? Do you guys understand that we just plugged in 3x for A and plugged in a negative 5 for B? Yeah, sort of. All right, so I know this still took us a minute to do, but if we had gone out and done it the really long way, so if we'd started with 3x minus 5 times 3x minus 5 times 3x minus 5, it would have actually taken us longer because we'd have to go through and FOIL, and then we'd have to go through and distribute a 3x minus 5 onto whatever we got and we FOILed. So this is a slightly faster way. And if we get to even higher exponents, that's whenever it really starts to make a big difference. So whenever you get to the 4th power, 5th power, 6th power, things like that. So factorial notation. Factorial is just going to look like an exclamation point, exclamation mark. And all it means is you're going to multiply whatever number that is times every number below it down to 1. So if you have 3 factorial, then that means 3 times 2 times 1. And so it would be 6. So it looks all nice and fancy here where it says multiply. So n factorial is n times 1 less than that, times 2 less than that, all the way down so you get to 1. So it's just saying you're going to take that number and every number below it, or every whole number below it, down to 1. Correct. There you go. And then the one thing to remember is that 0 factorial equals 1. All right, so 4 factorial can be 4 times 3 times 2 times 1. So 4 times 3 is 12. 12 times 2 is going to give us 24. So not too bad. And 5 factorial is not that bad by hand either. So 5 times 4 times 3 times 2 times 1. So the 5 times 4 is going to give us 20. 20 times 3 will give us 60. 60 times 2 is going to give us 120. But you also have a factorial button on your calculator. So for 5 factorials, we've done 5. And we do shift. And then right over here, we have that x to the negative 1. So it's going to be shift and then that button. And that's your factorial button. And you hit equal, and it's going to give us the 120. So it can save you a little bit of time. Yeah, so it's we're going to do shift and then x to the negative 1 to get that factorial. And again, I know that we can do 4 and 5 by hand, but whenever you get to stuff like 10 or 12 or 15, you're going to definitely want your calculator to do it for you. So we would read this just 4 factorial, and this one's going to be 5 factorial. So it's just whatever number it is, and instead of saying exclamation point, you just say factorial. Are you guys okay on that part so far? Yeah. All right. All right, so we're going to start talking about the binomial coefficient. So we're going to start using this notation, but it's not that big a deal, and I'll show you the quicker way to do it. So for non-negative integers and an r, with n being bigger than r, the expression n over r, which is going to be read n choose r, it's called a binomial coefficient and is defined by n factorial over r factorial times n minus r factorial. It can also be written as n choose r, NCR, so n choose r. So for A, I wanted to show you what it means and kind of work through it by hand really quickly, and then I'll show you guys the faster way to do it. So we're following this formula up here. So 8 choose 3 is going to be 8 factorial over the r is 3 factorial times 8 minus 3 factorial. Well, this is the same thing as 8 factorial over 3 factorial times 5 factorial. Well, I'm going to show you guys how we can reduce this sum. So this 8 factorial is the same thing as 8 times 7 times 6 times, and then 5, 4, 3, 2, 1. The 5, 4, 3, 2, 1 I can rewrite as 5 factorial. And then over 3 factorial times 5 factorial. Is that okay? Do you understand how I can go from 8 factorial to 8 times 7 times 6 times 5 factorial? Is that all right? Okay. All right, so then we have 5 factorial on top and bottom. And just like we normally would, we can cancel. And then we're almost there. So now I've got the 8 times 7 times 6 on top. On bottom, 3 factorial is 3 times 2 times 1. Well, this 3 times 2 times 1 is just 6, right? So we've got 8 times 7. Oh, make that a better 7. So 8 times 7 times 6 over 6. We can cancel the 6's. So then we end up with 8 times 7. And we get 56 after all that's said and done. Do you understand this process here? Like as far as just plugging in the numbers into the formula, so plugging it into this formula. On top? Okay, so the very beginning, just following this, it's telling us to take our n, or our top number. We do n factorial on top, so we're going to have 8 factorial on top. And then it wants on the bottom, that bottom number factorial, so that 3 factorial. And then we're going to do 8 minus 3, or that top minus the bottom. And the 8 minus 3 is just going to give us a 5. Well, it's 8 times 7 times 6 times 5, 4, 3, 2, 1. But instead of writing the times 5, 4, 3, 2, 1, we kept that as 5 factorial so that we could reduce these right here. So we could cancel them out. Okay? All right. Any more questions? All right, so after I've tortured you and made you go through all that, the reason we're making a big deal saying that this is the same as this, you're going to see this in your book. The 8 choose 3 will be written this way. But if you look on your calculator, you can do 8. And if you do shift, and then right over your divide symbol, there's a little NCR. And that's going to give you your C. So 8 choose 3 is going to give us 56. Go ahead and do the rest of these. All right, so let's talk about these guys real quick. So for the 7 choose 2, hopefully you did the 7, shift divide, 2, and got 21. Everybody get 21? Yeah. All right, super. All right, then we have 12 choose 1. So we're going to have 12, and then shift divide, choose 1. And we're going to get 12. Is that okay? All right, and then 100. Choose, oops, missed my shift. Choose 98. 4,950. Yeah, okay, good. And then we're going to do 100, choose 2. Oh. And same thing, 4,950. Yep, all right. All right, so this page is okay. You hope for lots of those. Yeah, all right. Okay, so let's talk a little bit more about these binomial coefficients. And there's an alternative method. So this is Pascal's Triangle. I was looking up I had to remind myself who it was. But if you look, there's a pattern here. So what we're doing, to get to each of these numbers, we're taking the two numbers above it and adding. So pretend that there's zeros lined all the way down. So to get to this one, so 1 plus 0 is 1. 1 plus 0 is going to give us 1. And we can do that all the way down. The 1 plus 0 is 1, so on and so forth. To get this 2, we go above it. The 1 plus 1 is 2. And then to get here, so again, 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. And then the 1 plus 0 is 1. And we can hop down here. It's going to follow the same pattern. The 0 plus 1 is 1. 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is going to be 56. 35 and 35, 70, so on and so forth. So this is Pascal's triangle, and it follows, you can get these numbers by doing the 0 choose 0, 1 choose 0, 1 choose 1, 2 choose 0, 2 choose 1, 2 choose 2. So you're doing 3 and then choose 0, 1, 2, 3, 4, choose 0, 1, 2, 3, 4, 5, choose 0, 1, 2, 3, 4, 5, coming across. And what you'll start to notice is that, so the 5 choose 0 and 5 choose 5 are going to be 1. And this 5 choose 1 and 5 choose 4 are going to be the same number. So here, let's go down here. So we've got, this will be our 0 choose 0, 1, 2, 3, 4. So here's our row whenever it's 5 choose everything. So this is our 5 choose 0 and our 5 choose 5. Here's our 5 choose 1. And our 5 choose 4. And then here's our 5 choose 2 and 5 choose 3 that are going to be the same. And so where the 2 and 3 are going to add to give you the 5, they're the same. The 1 and 4 are going to add to give you the 5. They have the same number, the same value. And same with the 0 and 5. So the 5 choose 0 and 5 choose 5. The 0 plus 5 is going to give you the 5. So they add to 5. And they are the same. Sorry, there we go, the 1 and the 1. So we can plug into our calculator, or for 8, choose 3. So this was 5, 6, 7, 8. So 8, choose, I know this is 0, 1, 2, and 8, choose 3 right here. It's going to give us 56. And again, you can just throw in your calculator also. So the 8, choose 3, and there's your 56. And then you guys try 7, choose 2 off of the triangle. All right, so using the triangle, we've got the top number will be the 0, 1, 2, 3, 4, 5, 6, 7. So we're going to be in this row. And then going across, we're going to have 7, choose 0, 7, choose 1, 7, choose 2. So it's going to be this guy right here. All right, so now we are finally getting to the binomial theorem. And part of the reason for the delay is that we needed to make sure that we were familiar with this here, the n choose 0, n choose 1, so on and so forth, all the way to n choose n. And again, n is just going to be whatever is going to end up, well, not again, but n is going to be the exponent. And then it's going to follow this formula that we take this first thing, so whatever's there, and then we're going to have a to the n minus 1, a to the n minus 2, a to the n minus 3, so on and so forth, until it's gone. So whenever we get all the way down to a to the n minus n, or a to the 0 power, anything to the 0 power is going to be 1. So we're not going to have it in our very last term. And then for the b, we're going to do that in ascending order. So we did descending order for the exponents attached to a. So the exponents were getting smaller for a, and with b, they're going to get bigger. Technically, there's a b to the 0 right here. But b to the 0 is the same thing as 1, so we don't worry about it. And then we have b to the first power, b to the second, to the third, so on and so forth, until we get to n. So this looks crazy, but it's really not that bad if you just kind of plug the stuff in and then slowly work through it. So here we have everything worked out for a plus b to the first, second, third, fourth, fifth. And again, that's just going through and giving you the examples. And the a's, again, they're going to be decreasing in power. So that first thing is going to be decreasing in power, starting with the fifth, because that's what power we have here. So there's your 5, 4, 3, 2, 1. And then technically there's a 0, but we wouldn't write it. And the b's are going to increase. So 0, 1, 2, 3, 4, 5. And then your coefficients, that's going to be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. And all that is following this here. So that exponent that you have in the original, that's your n, and that's the number that is going to be super vital in using your binomial theorem. All right, so let's do one. I think it'll be a little bit easier if we actually do one. All right, so this one's not bad. So we've got x and we've got 2. So our a, or our first term, is just our x. Our b, or our second term, is just a 2. So I'm going to show you guys the way I typically do it. So for me to make sure I follow the pattern, I know that I'm going to have 3 choose 0, and 3 choose 1, 3 choose 2, 3 choose 3. So now I'm going to have that. And then I know that for my first thing, my a, that I'm going to start with this power and then work my way down. So I'm going to have x cubed, x squared, x, and then I don't need anything here. And then for my second term, my b, I know that I technically have b to the 0 here. That's the same thing as 1, so I'm going to skip that one. So I'm thinking 0 power, and then first power, second power, and third power. And I know I've got plus signs in between all this. Or I should say, I know I'm starting off with plus signs between all of this. And then it's just a matter of going through and simplifying all this. So 3 choose 0 is going to be 1. If you're not sure, ask your calculator. So you got 3, and then choose 0. So there's your 1. Let's go ahead and do 3 choose 1. So 3 choose 1. It's going to give us 3. 3 choose 2, also going to give us 3. And then our 3 choose 3 will give us 1. So we had 1, 3, 3, 1. So for my coefficients, I know I've got this. Oops, let me switch colors. So I've got a 1, a 3, and a 1. And then I'm just going to go ahead and put these guys in there. So I'm going to have x cubed, x squared, x. And then here I'm going to have 2. 2 squared is going to be 4. 2 cubed, 2, 4, 8. And then we need to make this thing look pretty. So we're not going to have 1x cubed. We would just write that as x cubed. And then plus the 3x squared times 2 is going to give us a 6x squared. And then plus the 3x times 4. The 3 and 4 is going to give us a 12x. And the 1 times h is going to give us 8. The one really super important thing I want to make a note of for B. So your A is really easy, right? The A is the same thing as y. So your first term is just a y. It's your second term. Exactly. The B is a -3. So make sure whenever you're plugging that in, that you're plugging in that -3 with those parentheses. I'm going to give you guys a couple minutes to try that one. All right, well, we're going to go ahead and start this one. So, again, the way I start off is I go ahead and do my coefficient first. So the 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. I'm going to take this first thing, the y, so that the first thing's my y. And we're going to have that to the 4th power. 3, 2, and that's the first, which I know we don't need to write the 1, but I'm going to, because I'm going to try to prove a point in just a second. And then we're going to take our second thing, that -3. This is -3 to the 0 power, which is the same thing as 1. So I'm going to skip here, and I'm going to come here. So -3, and that's going to be to the first, -3 to the second, -3 to the third, so -3 to the fourth. All right, so we've got everything plugged in. We kind of need to crunch through it, but I want to point out a couple things. So whatever term we're looking at, so let's see, this is our first term, our second term, so here's our third term. Our third term, this is going to be 1 less, so third term, so that bottom number is a 2. I want you to notice that this 2 is the same exponent that's attached to the second part. So the 2 and the 2, a 1 and a 1. Technically, there's a 0 here, and there's a -3 to the 0 here. So this bottom number is going to match the exponent to the second part. And then I also want you to notice that these exponents are going to always add to the top number. So we've got 4. Okay, well, done. And then the 1 plus 3 is 4. 2 plus 2 is 4, 3 plus 1 is 4, and then the 4 is 4. So the exponents are going to have to add to that top number. And that bottom number is going to be the exponent of the second part, so of your B. Is that okay? Yeah. All right. So I'm going to put down my coefficients first. If you happen to remember what we just did, so we just did to the third power, and our coefficients were 1, 3, 3, 1. I can actually use that to get the coefficients for this. So 1, and then 1 and 3 will be 4, 3 and 3 will be 6, 3 and 1 will be 4, and then I'll have another 1. So those are going to be my coefficients. If you didn't do that, that's fine. You can just throw it in your calculator. So 1, 4, 6, 4, and 1. And so we're going to have y to the 4th, y cubed, y squared, y. And this is the part we got to watch because those negative signs. So we're going to have a negative 3. The negative 3 squared is going to be a positive 9. The negative 3 cubed is going to be a negative 27. And then the negative 3 to the 4th is going to be a positive 81. Did you all get those with the right signs? Yeah? All right. Good. Okay, and then we just need to make this look a little bit prettier. So we're going to have y to the 4th. And I was going to write plus, but I can't write plus. Because, so I've got 4y cubed times a negative 3. So it's going to give us a negative 12y cubed. And then over here will be positive. So we're going to have plus, and that's 6y squared times 9. It's going to give us a 54y squared. And then again, we're going to have a negative. So the 4 times a negative 27 is going to give us a negative 108. Is that right? Okay. So negative 108y. And then this 1 times 81 is going to give us a plus 1. And thank you for the plus 81 instead of just plus 1. Yeah. All right, this okay? Yeah. Yeah, this is it. And then you're done. So really, I mean, you're just plugging everything into that formula and then simplifying it. So it's a little bit of a process, and it looks kind of scary, but it's really not that bad. Okay, so I'm going to give you guys a couple of minutes and let you try C and D. All right, so we'll go ahead and get started. So again, I start with the coefficients, the 4 choose 0, 4 choose 1, so on and so forth. And then for our A, we're going to have our x squared. And then we're going to start with our 4, so to the 4th power, 3rd, 2nd, 1st, and then we're not going to have it here. Well, you could, but it's going to still turn it into 1. Because whenever you end up, so if you have x squared to the 0, because of our exponent rules, the 2 times 0 is going to give us 0. So we're going to end up with x to the 0, which is going to give us 1. So that's the reason we're not writing it at that last part, just to kind of save a little bit of effort and to hopefully reduce confusion. All right, then for our second one, that B. So we're going to have technically y to the 0. We're not going to write it. Then we're going to have y to the 1st power, y to the 2nd power, y to the 3rd power, and y to the 4th power. To double check, we're going to make sure that our exponents, so again, whenever I'm saying the exponents, I mean this 1 and this 3, not the squared, that x squared, not that squared that was already with the a. We're just looking at the ones that we put in. So the 1 and the 3 give us the 4, 2 and 2 give us 4, 3 and 1 give us 4, 4 gives us 4. And also that our bottom number is matching the exponent of our b term or of our second term, which it is for all of them. And again, I'm going to point out one more time that whatever term we have, this bottom number is 1 less. So for our first term, the bottom number is 0. For the second term, our bottom number is 1. For our third term, bottom number is 2. For the fourth term, our bottom number is 3. And for the fifth term, our bottom number is 4. So just trying to show you guys there's more of the pattern. All right, now we're going to go through and work on simplifying. So I know these coefficients because of the last one that we just did. So we had that 1, 4, 6, 4, and 1. Perfect. So the coefficient part's done. So now I'm going to go through and deal with all these x squared, so deal with the a's. So the x squared to the 4th is x to the what? Yes, x to the 8th. So we're multiplying those exponents. Because it's a power to a power, we're going to multiply the exponents. So x squared cubed, x to the 6th, x squared squared, going to be x to the 4th. And then x squared to the 1st is going to be x squared. And then we're going to go through and put in our y's. So we're going to have y squared, y cubed, and y to the 4th. And then once we're here, it's really easy. We're just going to rewrite it and leave out those 1 coefficients. So we're going to end up with x to the 8 plus 4x to the 6th y plus 6x to the 4th y squared plus 4x squared y cubed plus y to the 4th. So again, hopefully this isn't hard. It just takes a few minutes. Hopefully. All right. So one more. You guys do D. All right, I'm going to go ahead and start plugging everything in so we can make sure we get finished up today. So again, I'm starting with my coefficients. 5, choose 0, choose 1, choose 2, 3, 4, and 5. Then I'm going to plug in all of my a's. So I've got x to the 5th, x, and then to the 4th, to the 3rd, squared, and then technically to the 1st power, and then to the 0 over here, but we're not going to write that. And then for the b, that negative 3y, we technically have negative 3y to the 0 here, but we won't write it. Then we have negative 3y to the 1st power, negative 3y squared, negative 3y cubed, negative 3y to the 4th, and negative 3y to the 5th. All right, so for my coefficients, we just did the one that was to the 4th power, and we got 1, 4, 6, 4, 1. And this was for the 4th power. So 5th power, I'm going to have 1, 5, 10, 10, 5, 1. And again, you can just plug all this in your calculator if you want to. The 5, choose 0, all the way through 5, choose 5. So I'm going to have 1, 5, 10, 10, 5, 1. And x to the 5th, x to the 4th, x cubed, x squared, x. And then the one that's going to take a little bit of thinking is going to be that negative 3y. So we're going to have negative 3y to the 1st. That part's fine. And this negative 3y squared is going to give me what? Any ideas? Beautiful. Yes, it's going to be a positive 9y squared. So a positive 9y squared, because this is negative 3y times negative 3y. So it's going to end up to a positive. Here, we got a negative 3 and a cubed, so it's going to still stay negative. So we have a negative 27y cubed. The negative 3y to the 4th, the negative 3 to the 4th power is going to be a positive 81, and then y to the 4th, 81, y to the 4th. And then negative 3y to the 5th is going to be a negative 243, is that right? Thank you. So negative 243, y to the 5th. Whew, all right, almost, right? One last step, and that's just going to be putting it all back together. So here we're going to have x to the 5th, and then I've got a negative, so we're going to have minus. The 5 and the negative 3 is going to give us a negative 15, and then x to the 4th y. And then here we've got plus, so we got that 10, and that's a 9, so the 10 times 9 is going to give us a 90. X cubed y squared. And then minus, because we have 10 and a negative 27. So minus 270 x squared y cubed. And then here we've got two positives. So plus the 5 times 81 is going to be 405 x y to the fourth. And then this is a positive 1 times a negative, so minus 243 y to the fifth. Is that okay? You guys agree? Don't make any silly mistakes? Yes, it is a long process. It is definitely a long process. But it's still shorter than we wrote that out 5 times and went through the because you can only multiply 2 at a time, right? So you'd have to do 2 of them, and then times the third, then times the fourth, and it gets longer and longer and longer. So this is still shorter than the long way, but it still takes a minute. All right, everybody good with this? Yeah? All right, last page for today. And the last page is why I was pointing out a lot of the stuff that I was pointing out. So it's going to ask us to find a particular term. So to find a particular term, so the r plus 1 term, so if it wanted us to find the 8th term, so the 8th term is 7 plus 1, where r is going to be 7. But let me show you the way I was pointing it out to you. So back here, I was mentioning how whatever term we were on, the bottom number was 1 less. So our 3rd term, bottom number's 2. 4th term, bottom number's 3. So whatever term we're looking for, that bottom number is just going to be 1 less. That's all that this is really saying over here. It just doesn't feel as nice, I don't think. And it's just going to ask us to go through and work this out. And again, just paying attention to the pattern we had last time, it's not going to be that hard. So here it wants us to find the 6th term. So we need our coefficient first. If it wants the 6th term, we know that the bottom number is going to be what? It's going to be 5. So for the bottom number, and then you're right that this exponent, this 8, is going to be our top number. So the big exponent, the outside exponent, is always going to be the top number. And then whatever term it wants, we're going to do 1 less. So I've got my A and I've got my B. So my A is the x squared. So I'm going to go ahead and put x squared and just leave it there for a second. It says the 6th term here. So we're going to take 1 less. So the 6 minus 1 is going to give us the 5. So whatever term we want, we're going to do 1 less down here. And then we've got that B is y cubed. So we're going to go, so we're there. We also, or I tried to point out that this bottom number is always going to be the same exponent as the 2nd thing. So we're going to go ahead and put that 5 over here. And then we know that these exponents have to add to the top number. So what's this one? 3. So we know that these exponents are going to have to add to the top number over here. So the 5 and the 3 is going to give us the 8. I promise after you do like 20 of them, the pattern's really obvious. Yeah, like 20 or so. So for the 8, choose 5. I'm just going to pull up my calculator really quickly and do 8. Oops, missed it. Choose 5. Wow, sorry about all the double numbers. So 56. So we got 56 here. This x squared cubed is going to be what? Yeah, x to the 6th. And y cubed to the 5th is going to be y what? To the 15. Right. All right, so I know there's a negative half here for your second one. Don't freak out about it. I want you guys to try to set up B. So set it up. I mean, work through it if you can. That'd be even better. But go ahead and at least get it to this part. So figure out all the parts for here. All right, so let's go ahead and get started with it. So for our coefficient, what's the top number? 9. What's the bottom number? 3. Right, so whatever term we're after, do 1 less. All right, and then our A is what? Okay, and then our B is what? -1/2. Okay, and then what exponent goes with that -1/2? 3. What exponent goes with the x? 6. Beautiful. All right, so the 9 choose 3. I'm going to ask my calculator to help. So for the 9 choose 3. Yeah, and so, I mean, that's really all we're doing. We're just taking that top number, putting it over here. And if you're thinking about this 9 minus 3 gives you the 6, that's perfect. My brain thinks of it, the 3 plus whatever equals this. But either way is the same. And the formula is the 9 minus the 3 to give you this top one. So the 9 choose 3 gave us 84. And then x to the 6, that was no problem, right? And this -1/2 cubed, positive or negative? Negative. And then it's going to be negative what? 1/8. Super. All right, so this one's going to actually take just a second. So if I put this together, I've got -84/8 x to the 6. Then I can reduce this. Both are divisible by 4. So we're going to get a -21/2 x to the 6th. So we could be done there. We could have had -10.5, same thing, but -21/2 x to the 6th. Is that one okay? All right.